In early Showa-era Japan, there was a concept for a diesel super express, separate from the Tsubame super express. In the 19th century, railways were the main mode of land transportation, but in Europe and America, they gradually lost ground to automobiles and airplanes in the 20th century. Speed was the most effective way to counter this, and by the 1930s, efforts were focused on developing high-speed trains. Reciprocating steam engines structurally struggled with high-speed rotation, so steam locomotives responded by increasing the size of the driving wheels. Some even had wheels over 2 meters in diameter, but they hit a ceiling at around 200 kilometers per hour, and even 160 kilometers per hour was challenging for commercial operations. Attempts were made to overcome this with high-speed steam turbines, but steam engines were burdened with heavy and massive boilers and tenders, reaching their limits. The solution was electric operation, but at the time, there were only a few electrified sections, so attention turned to internal combustion railcars, which could be easily sped up. In Germany, a leading country in diesel technology, semi-concentrated electric diesel trains were developed, and several high-speed diesel trains began operations. Amid this global trend, Japan's economy, which had been depressed by the financial crisis and the Great Kanto earthquake, gradually recovered, bringing brightness and vitality back to society. To meet the growing transportation demand on the Takedo line, the Ministry of Railways began operating high-speed trains between Kanto and Kansai, already in service as the Super Express Tsubame. Although Tsubame's groundbreaking speed was well received at the time, achieving that speed with steam operation required significant effort and ingenuity. The steam produced by boiling water had to be discarded after use, an inevitable fate for steam locomotives. While electrification was gradually progressing, the relationship with the military made it unlikely to expect full electrification of the Takedo line anytime soon. Thus, attention turned to internal combustion trains. The Ministry of Railways also focused on internal combustion railcars and began testing the introduction of gasoline railcars. Its nimbleness and speed were groundbreaking, and during the high-speed test, which also served as the debut of the mechanical gasoline railcar, it caught up with the earlier Super Express Tsubame. During this test, it recorded a top speed of 108 km per hour, raising expectations for railcars even higher. However, due to the mechanical transmission, it faced the challenge of only being able to form short formations. Additionally, the use of gasoline, a dangerous fuel, was another issue, leading to the development of more economical and safer diesel railcars. Against this backdrop, the Keiha 43,000 type, a 3-car formation with electric transmission, was produced and began trial operations to see if it could be used for mainline trains. The formation consisted of two M1T, with 240 horsepower diesel generator sets mounted under the floors of the cars at both ends, and a shorter trailer car in between. Being electric, it allowed for total control, eliminating the need for the cumbersome process of having crew members in each car changing gears at the signal of a whistle. Mounting such a generator set under the floor was unprecedented globally at the time and was quite an advanced idea. However, the horizontally mounted engine, due to its underfloor placement, faced many issues such as lubrication problems, presenting numerous challenges. Nevertheless, expectations for railcars continued to rise. The Super Express Tsubame was so popular that extra services were run, and there was a growing demand for more accessible high-speed trains on the Takedo line. The diesel Super Express was planned to become a star of hope. The design of the Super Express vehicles had already begun in parallel with the development of the Keiha 43,000 type. However, it was not feasible to replace long-distance express trains with vehicles using new and proven power sources. Additionally, to make them suitable for mainline operations, upgrades to passenger facilities were necessary. Therefore, it was initially planned as a sectional Super Express between Nagoya and Osaka. As a Super Express, it was expected to have a top speed of 120 km per hour, faster than the Tsubame. Due to insufficient power with the underfloor mounting method of the Keiha 43,000, the power was concentrated at both ends of the formation, with the generator sets mounted above the floor. The intermediate passenger cars were 20 meters long, arranged in a 3-car formation, with a capacity of 192 passengers. The motive cars were equipped with 600 horsepower diesel engines, and in addition to that, DC generators, making weight reduction a challenge. As speed increased, track damage also increased rapidly, so axle load had to be minimized as much as possible. Therefore, the car bodies were shortened to 15.5 meters. The arrangement of the traction motors also took axle load reduction into consideration. The leading 3-axle bogie was a trailer bogie, while the trailing 2-axle bogie and one of the bogies of the adjacent passenger car were equipped with traction motors, making a total of 8 motors in the formation. Additionally, due to the placement of the generator set on the driver's cab side, the front became heavier, so a 3-axle bogie was used at the front to mitigate the increase in axle load. Although the generator set was large, it only occupied about half of the car body. The remaining space had to be utilized effectively. However, due to the anticipated severe noise and vibration, it was not used as a regular seating car. One car was used for placing the steam generator for heating and as a luggage compartment, while the other car was equipped with passenger service facilities, such as a buffet or a salon room. This formation was indeed modeled after German high-speed diesel trains, compactly designed for narrow gauge. How well did this 1,200 horsepower, 5-car formation perform? Since there are no specific records, we can only speculate based on the performance of the Kiha 43000. The Kiha 43000 could run its traction motors up to 120 km per hour, but due to being in the characteristic region, the tractive effort was minimal. On flat tracks, it could barely reach 95 km per hour. Assuming the generator efficiency and traction motor efficiency are the same, calculations with 1200 horsepower suggest that by lowering the gear ratio and shifting the constant power region of the traction motors to higher speeds, it is possible to achieve 120 km per hour operation. However, even with a slight gradient of 2 per mil, further acceleration would be impossible, similar to the situation during the high-speed test of the 151 series, which utilized a downhill slope to reach 163 km per hour. Although track conditions differ from those of the past, let's consider running on the Takeda line. After departing from Nagoya, it barely accelerates to near 120 km per hour, assuming a station passing speed of 100 km per hour. There are no such opportunities westward until Osaka. Between Tokyo and Nagoya, there are sections where it is possible to cruise at 120 km per hour by utilizing gentle downhill gradients. Observing the performance during the high-speed test section of the 151 series, in the opposite downhill direction of the actual test, it is hindered by a slight gradient of a few per mil. On the other hand, in the uphill direction where the test was conducted, it easily accelerates to 120 km per hour with the help of the downhill gradient and can maintain that speed. The first diesel express train in the real world, the Kiha 81, appeared more than 20 years after this plan. Comparing performance, the power-to-weight ratio of the Kiha 81 is nearly 20% lower than that of the Hatsukari formation. However, due to the power of the electric transmission system, it was almost equal in the mid-speed range. If development had progressed smoothly, there might have been a high-speed diesel express running between Tokyo and Osaka. Due to different track conditions, it cannot be compared with the Tsubame of that time, but it seems it could have shortened the travel time by more than an hour compared to the C51 hulled passenger cars. From the perspective of that time, it would have been a super express, greatly impacting the lives of the people. Amid the global arms race, diesel engines were gaining attention as a power source for ships. In Japan, there was even consideration of using a combination of diesel and steam turbines for the battleship Yamato, showing the attention given to diesel engines, although they were not prioritized for vehicles. The anticipated diesel Super Express was swallowed by the impending waves of war, and not even a prototype appeared. It vanished along with the standard gauge bullet train plan that was being advanced at the same time. It was an era when efforts were being made to increase the flow of people and goods by rail from the Chinese mainland to Europe. Given the emphasis on military transport at the time, the modernization of railways was urgent, and track reinforcement was prioritized from Tokyo to Nagasaki. With heavier rails, even electric diesel trains would face fewer restrictions. High-speed trains comparable to those in Europe and America might have been born. If there had been no war, high-speed diesel express trains might have been running in Japan earlier than in the real world. Imagining the sight of diesel express trains racing through a largely non-electrified landscape is quite enjoyable,